Welcome to Lesson 7 NS2, Multiplying and Dividing Rational Numbers. So after this lesson, we should be able to use the rules to help us multiply and divide with rational numbers. Keep in mind that process for how we divide with fractions and decimals and how we multiply with fractions and multiply with decimals, those processes will always be there. Now we're just adding on the next step of is my answer positive or negative. So let's give it a shot. So the rules for division and multiplication, so I'm actually going to draw little division signs above this, and you can do so as well in your notes. Okay, so the rules are the same for multiplication and for division. Keep in mind they are different than those rules, though, for addition and subtraction. All right, so this is where you have to take it slow and really just practice on memorizing and knowing these rules. So positive times positive, you've been doing this since you started multiplying and dividing, it's positive. Okay, and a negative times a negative is going to also give you a positive. So when your signs are the same, your answer is positive. Okay? Now that's different when we have signs that are the same when we add. That means that we get to keep the sign. So it's a little different here when our signs are the same. It's automatically positive. When it's a positive times a negative or divided by a negative, our answer is negative. Or negative times or divided by a positive, the answer is negative. So when our signs are different, our answer is negative. All right, so we're going to start by working out how this works with fractions. So the other thing that I'm going to add on to this, not only are we going to use the rules, but we're also going to work on cross-simplifying. So we can cancel any common factors that are in our diagonal numerators and denominators. Then, after doing so, we can multiply those remaining numbers. Okay, so as a reminder, when I have negative 4/5, that negative can be put with the 4 or with the 5. So it can be written as negative 4 over 5 or as 4 over negative 5. Okay, but it can only go with one or the other. It cannot go with both. If it goes with both, that fraction then becomes positive. All right, so looking at this cross simplification, we're going to cancel out those common factors on the diagonals. So what I'm going to do is I'm going to use different colored pens here. So I'm going to look at my diagonals. I have 7 and I have negative 2. What is the greatest common factor of those two numbers? Well, the biggest number that they can both be divided by is 1. So these will stay the same. This will stay as a negative 2 and 7 will stay as a 7. Let's take a look at the next diagonal though. So I have 4 and I have 8. 4 and 8 can both be divided by 4. That is the largest number that can divide both of them. Yes, they can both be divided by 2, but that's not the largest number. We want to try to use the biggest number that we can. So here, 4 divided by 4 is 1. If you want to write a little note here for yourself that that's how you got that, you can do that. But remember, it stays as the numerator. And then here, 8 divided by 4 is 2, and that's how you got the 2. Now we multiply our new numbers, so 1 times a negative 2. So positive and a negative, as we remember up here, gives me a negative. Positive and a positive gives me a positive. So my answer here is a negative 2/14. Now, I can still simplify a little bit, and that's going to happen. Cross-simplifying doesn't always mean that the answer we get is going to be in simplest form, but it's going to make the numbers smaller that we have to work with, and that's one thing that can make our lives a little bit easier. Right? So I do want us to practice the cross-simplification, and then also practice, is my answer negative or positive? So I will do the your turn problem number 1 with you, but then you are going to do number 2 by yourself, remembering that you have to first change any mixed number into improper fractions. So looking at this, I have a negative, so this one here is negative 9/12, times a positive, this is positive 15/10. So since it's a negative times a positive, I know my answer is going to be negative because the signs are different. Let's take a look at that cross simplification. So here I have negative 9 and positive 10. All right, we can ignore the negative for now, but still the largest number that can divide both of them is 1. So negative 9 stays the same, and so does 10. And then I keep them in their same spots in their fractions. And then I have 12 and 15. 12 and 15 can both be divided by 3. 15 divided by 3 gives me 5. And then 12 divided by 3 gives me 4. Now, you don't always have to write this little division problem that we're putting. I'm just putting it there so when you go back in your notes, you have the reminder of how you got that. All right. And then keeping in mind, here is my new fraction. So my new problem, because I know it looks a little funny, is negative 9/4 times 5 over 10. And we got the new 5 and the 4 by simplifying the 12 and the 15. All right, so then now here I have negative 9 times 5, and I know that that is negative 45 because the signs are different. 4 times 10 is 40. But now this is improper. It's larger on top than on bottom. The negative doesn't matter. That process is still the same. Okay, I can still make one group of 40 out of 45. I'm left with 5 left over out of 40. But that is a negative because of the fact that that negative 45 is there. So I can put that negative out in front of the whole number. All right, and then on this next one, I'll take a look at the sign with you, but then from here on out, the you tries are all on you. So here I have a negative times a negative. So since they are both negatives, look back at your rules. Negative times a negative means I'm going to have a positive for my answer. All right, but you are going to figure out the answer from here. And then for the rest of your turns, you have to use your rules to help you out. All right, dividing fractions. So remember, when we divide fractions, we actually take the reciprocal of the divisor and then change division to multiplication. So we looked at that. We said make mixed numbers improper, keep the first number, flip the second number, change division to multiplication. So IKFC. All right, so let's take a look at how that's going to work for the first problem. So we have 2/3 divided by 18/9. So 2/3 stays the same, that's our keep. And then 18/9 is going to get flipped to 9 over 18. So then now we're going to multiply. So I have 2/3 times 9/18. And we're going to use our cross simplification. So here I have 9 and 3. Both of which can be divided by 3. 9 divided by 3 leaves me with 3. 3 divided by 3 leaves me with 1. Then if I look at my other side, my other diagonal, I have 2 and 18. So now I can actually simplify some more. Both of these are divisible by 2. 2 divided by 2 is 1. 18 divided by 2 is 9. Now I can go ahead and multiply my new fractions, which are 1 over 1 times 3 over 9, and I get 3/9. Okay, and then I know my answer is positive because both of the numbers that I multiplied were positive. All right, so now it's your turn. You are going to try these on your own, and we'll go over those answers when you come back into class, keeping in mind that you have mixed numbers and whole numbers down here, and you have to turn mixed and whole into improper before you can do any multiplying or dividing. Okay, and then remembering those rules. Same signs gets you a positive answer, different signs gets you a negative answer. All right, let's take it to multiplying with decimals. The biggest thing, you guys, is just remembering how to multiply fractions and decimals and then looking to see how many positives and how many negatives you have. So a reminder, the first thing when we multiply with decimals is we're going to line up the numbers and multiply. So I'm not lining up the decimal. I only have to line up the decimal when I add and subtract. Here, even though my decimal is at the very far right side of the 6, I lined up the 5 and the 6 because the place value part of it comes at the end by placing the decimal. So line up the numbers and multiply. And then we're going to count the number of digits behind the decimals. And then we're going to move our decimal in our answer that number of spaces to the left. So here I have 2 numbers after the decimal. So when I place my decimal, so remember it starts all the way to the right, and then I move it 2 places to the left in my answer. Okay, and the only reason it was only 2 places is because there are no numbers after the decimal that comes after the 6. All right, your last step is to determine, is my answer positive or negative? Here, this was a positive times a positive, so my answer is positive. Let's go ahead and give it a shot. So first, what I'm going to do is I have negative 6 7/800 times 4/10. I line up my numbers, remembering I don't have to multiply the 0 because anything times 0 is 0, so you're not adding any value by multiplying that 0 out. So now I'm going to ignore the decimals and multiply. 8 times 4 is 32. Carry the 3. 7 times 4 is 28. Plus 3 is 31. 6 times 4 is 24. Plus 3 is 27. All right, now if I would multiply out the 0, I would add the 0 here because I'm done with the 4. 0 times 8 is 0. 0 times 7 is 0. 6 times 0 is 0. So there really is no reason to hold on to that 0. Okay, now if it's in the middle of a number, we absolutely have to do that. But if it's at the end, or if it's after a decimal at the end, or before a decimal, and not like a 10 or a 20, then we don't have to multiply it out. All right, so then now I have to count how many numbers are after the decimal. So here I have 2 digits, and here I have 1 digit, giving me a total of 3 digits after the decimal. So I have to move my decimal 1, 2, 3 places, 1, 2, 3 to the left. So my answer is going to be 2 712 thousandths. But now look at this. I have a negative times a positive, and that gives me a negative answer. So this has to be a negative 2 712 thousandths. Just like we were doing before, where we would take and figure out the sign of our answer before we actually did the math, we can do that here. We can look and say, okay, negative times a positive gives me a negative, and we can put that negative sign in right away as well. You don't have to wait until the end. The only part that I'm going to add to that is when we start to include more numbers. So like if I have something like negative 1 times negative 3 times positive 4. I understand that there are different signs here, but that doesn't mean that our answer is going to be negative. Okay, that only works when you're working with 2 numbers. All right, because if you look here, negative times a negative, these 2 negatives times each other gives you a positive answer. Then now you have a positive times a positive, which gives you a positive answer. All right, so keep that in mind. And we'll talk a little bit more about that as we move on. All right, you have these 2 you-try problems that I'd like you to do on your own, and we'll check your answers when you come back to class. And then last, we're going to look at division. Okay, so a reminder of your steps. So the first thing we're going to do is move the decimal in the divisor to make it a whole number. And then however many spaces we moved it in the divisor, we have to do the same in the dividend. So here, I have to move it 1 space to the right. So I also have to move it 1 space to the right. So this becomes 55 0/10 divided by 5. Next, you're going to divide using long division as normal, and you add on zeros as you need to because we don't work with remainders. The only way that we are okay with having a remainder is if it's a remainder that repeats, that tells us it's a repeating decimal, or if we're seeing that there's no pattern, then that's a decimal that doesn't terminate. It goes on forever, so it's an irrational number. But for what we're working on here, you are going to find that you're either going to get a pattern or you are going to get a terminating decimal. So as a reminder, the divisor goes on the outside, the dividend goes on the inside. And then we are going to bring up a chair for everybody at the party. And I can bring my decimal up right away, or I can wait to do that at the end. All right. And then 5 goes into 5 one time. 5 times 1 is 5. I'm left with 0. Bring down the 5. 5 goes into 5 one time. 5 times 1 is 5. 5 minus 5 is 0. Now, I can bring down this 0, and I know 5 goes into 0 0 times. Okay, and you can finish that out. Right, but if you end up with a remainder of 0, and then you're bringing down a 0, that means that 0 can just get added into your quotient. If you subtract and you have something left over, so 1, 2, 3, whatever it is, then you definitely have to bring down that 0 and divide it out. Okay, so I go back up. My answer here right now is 11.0. And then I have to check to see, okay, bring my decimal straight into the quotient and see, is it positive or negative? Well, it was a positive divided by a positive, so my answer is positive. So my answer is 11 and 0 tenths. All right, you are going to go ahead and give these two problems a try. Okay, I did change this one in your notes. I believe I made it 0 and 8/100ths. Okay, whatever it is in your notes is how you are going to solve it. Make sure that you're showing all of your work and taking your time, and then make sure that you're going back to determine, is my answer positive or negative? As always, if you have questions, make sure to write them down. You can throw them in an email to me. You can type them down or type them out onto your notes, or you can type them out onto Google Classroom, and we will go over them when you come back to class.